Okay, so in today's video we are just going to revise all the things till what we have discussed now, right? Since from the next video we will be going with the stoichiometry, means the calculations based on the balanced chemical equations. Now we'll be finding the number of moles, the mass, the volume in the chemical equations, right? Till now what we have done, we have calculated number of mole, given mass, a volume, uh, by the quotients, right, by the numericals. But from the next video we will be trying to calculate all those things in the chemical equations. So today we are just going with the revision of all the topics we have discussed till now, right? So initially we know that what is mole. Mole is basically a bridge which gives us connection between two parameters, the mass of the substance and the number of particles present in the substance. Alright, and 1 mole is equal to how much particles? It is equal to 6.022 into 10 to the power 23 particles, or you can say units, right? And this value is equal to Avogadro's number. Avogadro's number, right? This is Avogadro's number, which is basically denoted by capital N and small a, which is written down to N, right? So what is mole? A mole is basically a bridge which gives us connection between two parameters, the mass of the substance and the number of particles present in the substance. 1 mole is equal to 6.022 into 10 to the power 23 particles or units, which is equal to Avogadro's number, and Avogadro's number is denoted by Na. Avogadro is basically a physicist, Italian physicist Amedeo Avogadro. So the full name or its nationality was Italian. He was a physicist. Amedeo Avogadro. He calculated this value first time. That's why it has got the name as Avogadro's number. It is the honored, right? Now 1 mole of atom will have how many atoms? The 1 mole of atoms will have 6.022 into 10 to the power 23 atoms, right? Because we know that whenever there is a 1 mole, means there are 6.022 into 10 to the power 23 particles. If we have a 1 mole of atoms, there will be 6.022 into 10 to the power 23 atoms. And if we have 1 mole of molecules or 1 mole of gas, it will have 6.022 into 10 to the power 23 gas molecules, right? Because we have 1 mole of gas, right? So 6.022 into 10 to the power 23 gas molecules. Then we have discussed some important formulas. We have discussed about 3 important formulas to find the number of moles. Those all 3 formulas are to find the number of moles. But if the number of moles are already given in the question, then you can find given particles by that, you can find given volume from that, or you can find given mass with the help of that formula as well, right? Basically these 3 important formulas are for finding number of moles, right? Number of moles. So the first formula we discussed about was number of mole when we have basically given mass in the question, right? If you have given mass in the question, you will be using the formula, and that of course would be equal to number of mole is equal to given mass, gm means given mass, mm means molar mass. Molar mass you can find by yourself, as I have already taught you how to find the molar mass of any compound or element, right? Now if you have volume given in the question, if volume given in the question, then your formula would be number of mole is equal to given volume, GV means given volume, and GM means, sorry, here I should write MM means molar volume, MV, sorry, and that is always equal to 6.022, sorry, 22.4 dm cube. So GV upon 22.4 dm cube number of mole, right? So if you have number of particles given in the question, then what formula you will be using? Let's write that too, right? If particles given in the question, then the formula would be number of mole is equal to given particles upon Avogadro's number Na, and of course that is equal to 6.022 into 10 to the power 23 particles, right? So we have discussed about three important formulas as well. When the given the mass will be given in your question and they will be asking for the number of mole, then you need to use this first formula, in which number of mole is equal to given mass per molar mass. If they have given moles in the question and you need to find the given mass, then again you will be using the same formula, number of mole is equal to given mass per molar mass. But if they have given the volume in the question and they are asking to find you the moles, then you need to use the formula number of mole is equal to given volume per molar volume, and molar volume of any gas at STP, standard temperature pressure, is always 22.4 dm cube or 22.4 liter. But if the number of mole is already given in the question and they are asking you to find the given volume, then again you need to use the same formula, number of mole is equal to given volume per molar volume. In that case, molar volume will be multiplied with the number of mole, thus you will have your given volume, right? Come to the third one, which is the again very important formula to find the number of mole. If they have given the number of particles in the question, then you need to use the third formula, which is number of mole is equal to given particle, which is already given in the question, and divided by Avogadro's number, which is equal to 6.022 into 10 to the power 23 particles. These are the particles which are present in the 1 mole of the substance. That's why you're dividing the given particles, which is given in the question, by 6.022 into 10 to the power 23 particles. But if they have given the number of mole in the question and they are asking you to find the given particles, then you'll go write the number of mole value which will be given in the question. Avogadro number you already know, 6.022 into 10 to the power 23. Now you need to find the given particle, right? So you will be multiplying Avogadro number, which is equal to 6.022 into 10 to the power 23, by number of mole which they're going to assign you in the question, by what you can find your given particles as well, right? So now these three formulas are, I guess, crystal clear to everyone. In the next video or from the next video, we're going to start our main chapter, right? The main chapter we had was what? It was stoichiometry. But for understanding the stoichiometry, we need to find the concept of the mole first, since we will be solving the chemical equations or balanced chemical equation. When we'll be finding the moles, mass or volume or particle, initially we'll be applying the mole concept, right? By applying the mole concept, we're gonna find the number of moles, the particles, the mass, the volume, everything. But initially we will be applying the mole concept. What is the mole concept? Initially we will be finding the mole of every compound or every substance which will be present in the chemical equation, right? We have learned how to balance the chemical equation, right? But from the next video we are going to learn how to apply the mole concept in the chemical equations. So this was all for today.